we left off and are ready to pick up on H. And I forgot what, are we going to do all of these? We'll see if we do the back two or not. I don't remember. But we're ready to talk about H. The integral of sine inverse x over the square root of 1 minus x squared dx. Now, any thoughts of where to start? Any guesses, I should say? And remember, if you see something and then you also see its derivative, that could be a good indicator of what you want to make u.
I think the denominator is the derivative of sine inverse, but I don't know which one you want to do.
Okay, so if the denominator is the derivative of sine inverse, so the numerator, then you want to use u as like the original. That way we can then, du will be the derivative. So we're going to want to use u as sine inverse. Now, yeah, there's not a good page of derivatives here. I'm going to look and see. No, that didn't have the inverse functions. Okay. Okay, so we are going to look at sine inverse as our u. So u is sine inverse of x. Okay. Now, as normal, what about du? The derivative of sine inverse.
The square root of 1 minus e squared u.
Okay. 1 over the square root of 1 minus, and I'm going to say x squared because it's x in this problem, and then dx. So that's one, and again, I know it's first semester. Good one to recognize. The derivative of tan inverse is 1 over the square root of 1 minus x squared. Okay? Now, with that in mind, if my numerator is u, what do you see here? There's dx and there's square root of 1 minus x squared in the denominator. Does this match up? Yeah, it matches up. So when we go and rewrite this, there's going to be a u on top, right? For sine inverse x. And then what about this square root of 1 minus x squared in the denominator dx? What's it going to be replaced with? Du. So this one actually works out really nicely in that your u and your du take care of everything. So what is the integral of u? Okay. 1/2 u squared. Officially, since it's indefinite and no bounds, I'm going to throw on a plus c. Don't stop here. It's indefinite and no bounds, so we need to replace u. And I'm going to write this as 1/2 times sine inverse x, quantity squared, plus c. Okay. Definitely a little easier than G. Okay, questions? Okay, in the next section, what's changing up?
There's bounds.
There's bounds, right? So we're going from indefinite integrals where we throw on a plus c to definite integrals where we have to plug the numbers in at the end and evaluate. So, however, other than that, it's a lot of similar stuff. Integral from 0 to pi over 2 of 1 minus sine x over x plus cosine x dx. Thoughts on what you would like to make u?
X plus
You want to go for the whole thing, x plus cosine x. Now, does this work out the way I want it to? Derivative of u is du. Derivative of x plus cosine x. Derivative of x is 1. Derivative of cosine x, negative sine x. And then, of course, dx. Okay. Does that work? Yeah, looks like it works here. You've got x plus cosine x is going to be our u. 1 minus sine x dx is going to be our du. So we're going to have 1 over u du. What's the catch? The bounds, yes? These bounds right here are in terms of x. If you want to use those bounds, you can. That just means that you're going to be, after you integrate, you're going to put in x plus cosine x back in for u, and then put your values in. If we don't want to have to go back to x's, we need to change these bounds. Remember doing this the other day? When x is 0, what's the definition for u? U is x plus cosine x, so 0 plus cosine of 0. Cosine of 0, 0. Cosine of 0 is 1. So my bottom bound becomes 1. And then when x is pi over 2, u becomes pi over 2 plus cosine of pi over 2. Well, pi over 2 is just pi over 2. What is cosine of pi over 2? Cosine of pi over 2 is 0. So that means my u value is pi over 2. So instead of going from 1 to pi over, or 0 to pi over 2, we're going 1 to pi over 2. Okay, integrate. What's the integral of 1 over u? Natural log of u. Evaluated from 1 to pi over 2. And then you guys remember how to sub in, yes? Natural log of pi over 2 minus natural log of 1. Now, you would assume this would be a non-calculator problem. Okay, so we're going to leave our answer in some type of form along this lines where there's natural log of u, or natural log, I mean. Natural log of pi over 2, I don't know, it's some decimal. Natural log of 1.
0.
Natural log of 1 is 0. That's one you need to know. You need to memorize. Okay, so that is 0. So then we're just left with natural log of pi over 2. And I don't know how well you guys know your graphs, but if you recall, because here's, every time I get confused and have to pause and think, natural log of 1, natural log of 0, I think about the natural log graph. The log graph, or natural log graph, looks like that. It doesn't exist in the negatives, thus we can't have natural log or log of a negative. It doesn't exist at 0, okay, so you're not going to be doing natural log of 0, and it crosses the x-axis at 1. So thus, the natural log of 1 is 0. I don't know if that helps or not, but it helps me. Okay, B. Thoughts on what to make u? I don't want to make it the whole thing, or it kind of defeats the purpose. Because e to the 2 minus x is all there is.
2 minus x.
We're going to go 2 minus x. And it might seem kind of silly to make it the entire exponent, but it's not. It's going to work out nicely. So if u is 2 minus x, what's du? Negative x. Whoops. You said it right. I didn't process it right. Derivative of negative x is not negative x. Yeah. Negative 1 dx. Or just negative dx is what you guys probably wrote. What should I probably do here?
The x is 2.
What'd you say?
Do the thing we did. Wait, Huh?
Is this going to match up? We're going to have e to the 2 minus x is u. Dx. I have dx. Do I have a negative 1? No. So negative du is equal to positive dx.
Is that right?
Say what?
Then we don't have an e.
Well,
Is that right?
e is still going to be here.
Okay.
It's going to be e to the what? E to the u. And then dx is represented by negative du. So it's negative integral of e to the u du. However, we need some boundaries. When x is 1, what's u?
1.
Happens to be 1. When x is 3, what's u? Two minus 3, which is negative 1. Okay.
So we have a negative, which we think
Okay. Our boundaries are reversed from what they should be, yes. We need to have the smaller on the bottom. Kind of works out to our advantage, though, because there's already a negative out front. So when you flip them, that negative becomes a positive. So this is going to be the integral from negative 1 to 1 of e to the u du. Integral of e to the u is e to the u. Evaluated from negative 1 to 1. So we're going to do what? E to the first minus e to the negative first. How should I express that? Because you're probably not going to see this answer on a multiple choice problem. Hmm?
E is first minus 1.
What do we know about e to the negative first? 1 over e. Okay. I would expect, and I can't guarantee it, but I would expect you'd see an answer like that. A negative exponent moves it to the denominator. Okay. Okay, let's keep moving. C.
X squared. Two to the x. Or 3. No, no.
We've got to pick something to do.
It's either 3 over x or x. It's one of those two.
I agree.
3x. I'll go x squared.
u is the 3 over x, and it'll all make perfect sense here in a moment. Okay? If you trust me, it'll make perfect sense in a moment. Now, in order to do the derivative of 3 over x, what do you know about 3 over x?
3x to the negative first.
This is 3x to the negative first.
Yes.
What's the derivative of 3x to the negative first?
Negative 3x to the I u second, right?
Now, think about this. I'll write this in a different form. Negative 3x to the negative second is negative 3 over x squared. Are magic things happening? There's an x squared in the denominator, right? That's the magic. That's what I'm calling it. Okay, so, okay, where are we at here? 3 over x. That's going to be your u. E is just going to be there, so e to the u. X squared dx, x squared in the denominator, dx is what's equal to du, so we're almost good.
You have to divide by 3. Or multiply. No, divide.
It's in the numerator, so we're going to divide by 3. I'm going to divide by negative 3. So when I divide by negative 3, I'm going to think of this as negative 1/3 du is equal to 1 over x squared dx. Or if you want, you can think of it as multiplying by negative 1/3, because multiplying negative 1 over 3 and the negative 3 on top would cancel. Okay. Oh, we need to change some bounds, don't we? If x is 1, then u is 3 over 1, which is 3. If x is 3, u is 3 over 3, which is 1. That's not the confusing part at all. Okay, so the integral. Okay, e to the 3 over x becomes e to the u. X squared in the denominator times dx. Well, that's right here. X squared in the denominator times dx is negative 1/3 du. My boundary that was 1 is now 3. My boundary that was 3 is now 1. And if you want, you can flip, yes. There's a nice convenient, it gets rid of the negative, so it becomes positive 1/3 times the integral from 1 to 3, e to the u du. 1/3 times, what's the integral of e to the u? E to the u. Evaluated from 1 to 3. You can, if you want, leave the 1/3 out front. It's a constant, right? Times e to the 3rd minus e to the 1st, which is just e. Now, personal opinion, that looks good to me. Okay. Other thoughts?
1/3 minus 1/3.
You could distribute the 1/3. What's in common in those parentheses?
1/3 e to the second.
They both have an e in common, yes? And I just,
1/3
guys,
squared.
realize I'm fine with this. I'm not saying that we have to go farther, but multiple choice. Can you identify equivalent multiple choice answers? Okay, that's what I'm going for here. So they both have an e in common, yes? You factor that e out. You could write it as e over 3 times e squared minus 1. That's equivalent, yes?
Yeah.
Would you see it? Okay. So, the only other option I have is like putting it together as one fraction where I have, and there's lots of options, but I have e times e squared minus 1 all over 3. I'm not even saying these are all the options, just be able to recognize equivalencies. That's just multiplying this together. Okay? Is Augie sold on it?
Yeah.
Okay.
I'm just thinking, I don't know if I recognize it, but I think I second guess myself enough to where I would, like, I can always multiply those out.
Well, and that's exactly what I would suggest. You get an answer like this, and you feel confident in your answer, and you're like, man, I'm seeing similarities, but not the exact thing. Start multiplying some of these together. Multiply yours out of, start doing some manipulating between the two and see what you can figure out. Okay, D. What's U?
2x.
Bigger.
1 plus e to the 2x.
I like it.
Oh, dang it.
Okay. If U is 1 plus e to the 2x, what's du?
E to the 2x times 2.
Okay, you guys with her? The derivative of 1 is 0. It's gone. The derivative of e to some power is e to some power times the derivative of the power, and the derivative of 2x is 2. Okay. Is good stuff happening? Yeah, it's matching up. Have you changed your bounds? If x is 0, u
Is. What's e to the 0?
what's anything to the 0?
0. 1.
1. Oh, we talked about that yesterday, didn't we? I was like, that came up recently, but it was probably yesterday. So, okay, so e to the 0 is going to be 1, and 1 plus 1 is 2. If x is 3, then u is 1 plus e to the 6th, and that's just that. That's not getting any better. Okay? So, the integral. It was from 0 to 3. Now it's going to be from 2 to 1 plus e to the 6th. But here's the deal. We're going to be plugging into u. I mean, it was either that or you're plugging in 0 and 3 to some other crazy stuff. So, pros and cons. Let's see. 1 plus e to the 2x is my u. 2e to the 2x dx is my du. So the integral of 1 over u. Natural log of u, evaluated from 2 to 1 plus e to the 6th. So natural log of 2 minus natural log of 1 plus e to the 6th. Yeah.
That's about it.
That's about wrong.
Yeah,
What?
you flipped them.
Did you guys follow my mistake?
Oh, I see it. I do that.
Upper minus lower? I did lower minus upper.
So lower's right there.
The only reason I caught it is because I glanced at my answer key. Caitlin, I hope you would have spoke up and said, what? Why? I don't know what got into my brain, but natural log of the upper, 1 plus e to the 6th, minus natural log of 2. No idea why I messed that up, but don't always trust your teacher. That's the lesson to be learned there. Okay. You got something for E?
X.
XO?
X squared.
To the
5x squared. 5 to the x squared.
x times 5x squared.
Can't do it all. X squared.
Yes.
Okay. U is x squared. What's that mean du is? 2x dx. Good news, you see an x there, yes? What's missing? The 2. So 1/2 du is x dx. If I go ahead and change my boundaries, if x is 0, then u is 0 squared, or 0. If x is 1, then u is 1. Right?
Yes.
Doesn't happen that way often, but we'll take it. Okay, guys, so the integral from 0 to 1, say 0 to 1, 5 to the power of x squared is now going to be 5 to the power of u. X dx is 1/2 du. And you can put the 1/2 in with it, but it just messes me up when I have too much in there. Okay. 1/2 times the integral of 5 to the power of u. It's on page 390 at the beginning of this lesson.
Let's see.
It's the
5 u over natural log of 5.
5 to the u over natural log of 5. Evaluated from 0 to 1.
Yes.
Which, debating what my suggestion will be here. Okay.
That's 5.
Okay. The 1/2 can just stay out front. Technically, that natural log of 5 can go out front if you want, but 5 to the u, so 5 to the first over natural log of 5 minus 5 to the 0 over natural log of 5. 5 to the first is 5 over natural log of 5. 5 to the 0, 1 over natural log of 5.
Is this going to work? 4 over natural.
Is there a common denominator?
Yeah.
There's a common denominator of natural log of 5. So this is 1/2 times 4 over natural log of 5. Which, put it together,
Could you,
4 over 2 natural.
I was gonna say, could put 4 and 2, like,
Oh,
do that
that's
one thing.
I personally would cross cancel here. And so then I'm going to say 2 over natural log of 5. Now, Tate started to say 4 over 2 natural log of 5. Equivalent, realize that it needs to reduce to that, right? And my thing is, once I put it together, I don't see that reducing as easy in that scenario. So, both good. Okay, F. It's Tuesday, right? It's a rough day.
Cosine X.
Uh-huh. U is cosine X. Du. What's the derivative of cosine X? Negative sine X. dx. We don't have a negative, so we'll put the negative over here. Negative du is equal to sine x dx.
Not at all. Transfer those.
Transfer your things.
Okay. When x is 0, then u is cosine of 0, and cosine of 0 is 1. When x is pi, u is cosine of pi, u is negative 1. I feel like they're all working out like this. Okay, so it was 0 to pi. Now it's 1 to negative 1. E to the u. And sine x dx is negative du.
Flip them.
Okay, easiest option here is to flip. So you're doing the integral from negative 1 to 1 of e to the u du. I think we did this exact integral earlier. E to the first minus e to the negative first. So e minus 1 over e. I don't know that they would, but keep in mind, this could also, e with a common denominator of e is e squared over e minus 1 over e. So this could also be written as e squared minus 1 all over e.
Lost me. It's a good.
Basically, I thought of this e as e over 1.
Yeah, multiply the e out.
And if I'm getting a common denominator of e, I'm multiplying by e over e. And so it becomes e squared over e to get that common denominator.
Right.
He's not with me.
That just
I
seems
am
like.
now, but
Now.
It's a lot of E.
And here's the deal. I think most of the time you would see e minus 1 over e. However, that's most of the time. Could you see that one?
Yeah.
You could. Okay, guys. Looking at 3 here. 3a is evaluating by completing the square. Okay. With this in mind, we didn't get to our completing the square examples in the last lesson. Okay. And did you even see any in notes or in homework? That just dawned on me. I don't know if you even saw any in homework.
I don't think so.
If you did, you didn't ask about them. So.
I don't think there were any.
Yeah, so, okay. Well, as you look at this first one, the square root, or the integral of 1 over x squared plus 12x plus 37, this is a scenario that we can't really do much with it as is. Okay? And so, the suggestion here is that you can complete the square in the denominator, and then we will be in a form you can work with. Now, so let's review completing the square because you've slept a lot since then, right? So x squared plus 12x plus, leave a blank, right? And here's the deal, guys. Are we remembering what completing the square is?
Kind of, but like no.
Okay.
I remember now.
Okay. I guess it's pre-calc I've done a lot of completing the square with this year, and then we haven't really done much with you guys this year. So, completing the square is we're trying to make this a perfect square that factors. Now, x squared plus 12x, so this is your, if you recall, it's your x squared plus bx is the piece you want. This plus 37, I'm going to move it outside. Sometimes we would, if we were working with an equation, we'd move it to the other side of the equation. Now, in order to complete the square, we're going to use b over 2 quantity squared. Okay, what is b?
12.
b is 12. So 12 over 2 quantity squared. 12 divided by 2 is 6. 6 squared is 36. Now, here's the deal. We're going to add 36 into that gap I left.
So we have to move it to the outside.
What you do, we have to keep things equal here. And since I added 36 in here, we're just in working with an expression, we're going to subtract the 36. If you're on opposite sides of the equation, you'd add and add. But I don't have an equation here. So that's adding 36 and subtracting 36. Have I changed the value here? No, because I've essentially added a net value of 0. Okay. This stuff in parentheses factors into 2 identical parentheses, right? X squared breaks into x times x. Square root of 36 is 6. Keeping in mind, 6 times 6 multiplies to be 36. 6 plus 6 adds to be 12. Since it's adding to be positive, we're going to say plus 6. So x plus 6 quantity squared, and then when you clean up the outside, there's a lovely plus 1. Okay. I haven't even started the problem yet, really. All I did is rewrite here. Oh, that's interesting. That's not exactly how I showed it in my notes, but that's all right. That's what you guys have seen before, so we're going with it. Okay, so we're going to rewrite this as the integral of dx over x plus 6 squared plus 1. Now, this goes along with something we did yesterday.
Sure.
Okay? This is in a form of something we did yesterday.
Tangent.
This is tangent inverse. Okay? This is tangent inverse. Now, okay, let me write out. It was the integral of du, and usually I'll write it as is, a squared plus u squared, and that's going to be equal to 1 over a tan inverse of u over a, and then of course plus c. Okay? Now, this in green is just me like, this is what we need to remember. Okay? Okay, that could be copied from back that page 390 or whatever it is. Start with, like we did yesterday. We need to know our a and our u.
A is x plus 6.
Now, realizing,
Take a shot.
well, okay, here's the deal. Something is x plus 6, but it's not a. Because a represents our number, and u represents our variable.
1.
Okay, so the idea that a squared is in the place of 1, in other words, it's just flipped, right? A squared is 1, which then means, yes, a is 1. What is u squared in place of?
X plus 6.
U squared is x plus 6 squared, so thus u is x plus 6. I guess I didn't need to necessarily write a squared and u squared today. We know a and u, folks. Yesterday, one of the things we did is we then did du. However, what's the derivative of x plus 6?
1.
Just 1, so du is equal to dx. There's nothing to compensate for there, if that makes sense. So we're ready to write our answer. We're filling this piece out here. 1 over a, so that's going to be 1 over 1, which is 1. Tan inverse of
X plus 6 over 1. So X plus 6.
and plus c. That's it.
Alright.
Okay. So that's one of those little oddities. It's not your norm, but it's an oddity. Let's look at B.
4x minus 9.
Well, remember, notice it says evaluate by completing the square.
Forgot this.
So let's worry about what we have under the radical, which is negative x squared plus 4x. I just flipped it. My brain has to see the x squared first. And I think your brain will do much better if you see the x squared first. Now, if you recall from what I said, in order to complete the square, you have to be in the form x squared plus bx, where it's a positive x squared, a positive 1x squared. In other words, there can be no coefficient on x squared. What do we have here? We have a negative. So we're going to factor a negative out of these terms. So we're going to factor, it's going to become positive x squared minus 4x. And I'm going to leave a gap before I close my parentheses. Okay? And there's no number out here. I mean, you can think of it as you want, there's no number to move out here. There, you want a 0 out there. Does that make you happier? I mean, but that's the idea. There's nothing out there. Okay? Now, okay, b over 2 quantity squared. What's my b value? Negative 4 officially. Negative 4 divided by 2 squared. We're going to get 4. Now, we're going to add 4 in the parentheses. Now, to keep it consistent, officially, if you add 4 here, we are subtracting 4 here, yes? Now, there's one slight catch. If you had anything you had to factor out, keep in mind this 4. Is this 4 really just a 4? It's multiplied by negative, so it's really a negative 4. This 4 over here, that was really weird what it did. You're multiplying by negative 1. You're multiplying by anything that was factored out up here. We're trying to keep this equal, right? And so right here, this negative and this 4 is officially a negative 4, yes? A negative 4 times a negative 1 is officially a positive 4. Am I equal? Negative 4 plus 4 is 0. Okay? This is a way to show it. There's shortcuts. You can use shortcuts. That's fine. But that's what I needed you guys to understand. And I guess I've really not realized how much we have not completed the square this year. Because you guys were getting to be pros at this in pre-calc. No?
I don't remember.
Okay. Now, the idea here. There's a negative here. What's this factor into? X minus 2, quantity squared, and then plus 4. Okay. Now, let's rewrite this integral. Dx over square root. Now, folks, if you recall, I flip-flopped my problem to begin with, yes? And that negative out front is kind of, there can't really be a negative out front like that, but here's the deal. Let's flip-flop this. It's a 4, and then it's a minus x minus 2 squared. Well, this is going to fit a certain form now.
The sign.
Yeah. It's not a tan inverse, because tan inverse is like 1 plus x squared in the denominator. Sine inverse is a square root of 1 minus x squared.
Oh,
And this is the fancy version. So if you go back to that page, the integral of du over the square root of a squared minus u squared is equal to sine inverse of u over a plus c. Okay? This case came, it's straight in your notes, right? This is copied from like page 390 or whatever. But, are you seeing the form? What's A?
2, wait. Is 2, yeah.
Or I could ask what's A squared? A squared is in the place of 4. So if A squared is 4, then A is 2. What's U?
X minus 2.
X minus 2. What's my answer?
Sine inverse. So, X minus 2.
Yes.
You got it.
Hooray.
And I'll take that as perfect timing. I wasn't convinced we were going to do the next example 4 ones anyways, so
Nice.
that'll work. Example 4, it's change of variables, but there's challenges. They're not your average run-of-the-day problems. So, okay, guys, you have homework? 6.8? Get it done.